Well, scientists are predicting that a new ocean could be created as Africa gradually splits into two separate parts in the future. Researchers are warning that if a crack on the continent continues to large and separate, it will see countries like Zambia and Uganda have their own coastlines. But that could happen millions of years from now. CDTN's Nico Ramirez.
NASA just announced the African continent cracked open. The Earth. NASA revealed a terrifying situation fast approaching on the horizon for the African continent, and things don't look good. Reports have claimed that the entire landmass of Africa could be undergoing some pretty rapid changes soon. NASA has been monitoring the situation day and night to try to keep it under control, but how bad could things get? And what could it mean for the future of the continent? Join us as we delve deeper into how Africa is set to change in the upcoming years. A bountiful nation. For a considerable duration, Africa has captivated the interest of researchers and scientists due to its diverse tribes, extensive wildlife, and abundant mineral resources. However, a recent development has added a new layer of intrigue for scientists, one that was not anticipated. Scientists are cautioning about a significant crack emerging in Africa that could eventually divide the continent and give rise to Earth's sixth ocean. This transformative process would result in the creation of a massive island extending from Ethiopia to Mozambique along the southeastern coast. While it might seem strange, it's important to remember that the Earth's surface is always changing even though we may not notice it happening quickly. The way our world looks now is quite recent, shaped by the slow movement and interaction of large tectonic plates that fit together like puzzle pieces. Simply put, tectonic plates are big rock pieces making up the Earth's surface. They come in different sizes and thicknesses, with some stretching across very long distances. The Pacific and Antarctic plates are the largest ones. The Pacific Plate, below the Pacific Ocean, is really big, covering 102 million square kilometers and being 100 kilometers thick. On the other hand, the Antarctic Plate is 60 million kilometers wide with a thickness of 56 kilometers. Understanding these geological facts helps us see how our planet is always changing. The oldest continental plates are typically the thickest, ranging from 50 to 200 kilometers. We call these continental plates. On the flip side, the thinner plates, measuring less than 50 kilometers, are known as oceanic plates. Whether thick or thin, all plates have something in common: tectonic boundaries. Each continent has its plate or plates with clear boundaries, although these are hidden beneath the oceans and not visible to the naked eye. Scientists at NASA use GeoSat satellites in outer space to map out these boundaries. Tectonic movement. These plates are not still, they move at different speeds compared to each other. To understand this movement, think about the Earth splitting around 138 million years ago, when South America and Africa separated. If you look at the west coast of Africa and the east coast of South America, you'll see that they fit together like two puzzle pieces. This beautifully shows how these continents were once joined together as a single landmass. The same goes for all the other continents. About 300 million years ago, the Earth had no continents or many oceans. There was only one huge supercontinent named Pangaea and only one ocean named Panthalassa. Over the years, this continent slowly broke apart and spread out to form the many continents we see today. This process is called the continental drift. Scientists believe that the heat from the planet's core facilitated the creation of several rifts that broke Pangaea into the 7 continents we see today. The idea of all the continents being one large continent may be hard to believe, and you may be wondering what evidence researchers have to support this claim. Well, there are a couple of things that prove this claim. One of them, as we mentioned earlier, is the similarity in coastlines. Check each of the 7 continents and compare them to their nearby counterparts. You could almost fit them all into a single puzzle piece. Note that these coastlines have been weathered by the elements over the years. Initially, when these continents first formed, the plate boundaries were a perfect match. Another strong piece of evidence that Pangaea existed is our current geologic records, especially coal deposits. Geologists realized that the coal deposits in Pennsylvania, United States, are very similar in composition to those found in the UK and Germany from the same period. This shows that what we now know as North America and Europe was once a single large landmass. In addition, Some identical plants and sediments have been found on multiple continents, indicating that once upon a time, these landmasses were a single whole. For instance, a plant named seed fern Glossopterus has been discovered as fossils in diverse continents. Geologists have also realized, through careful investigations, that the rock formations of most mountain ranges around the world are identical in composition. This made geologists conclude that most of the spectacular mountain ranges we have today, like the Appalachian Mountains in the US and the Atlas Mountains in Africa, were once a single whole called Central Pangea Mountains, the Eastern African Rift. This geographical phenomenon is thought to have begun about 22 million years ago. Recent increased activity over the past few decades has reignited scientific curiosity. In 2005, a visible crack appeared in the deserts of Ethiopia, signaling the ongoing tectonic process. This crack has been expanding at a rate of 1 inch per year. The Eastern African Rift results from the gradual drifting apart of two tectonic plates, the Somali Plate in the east and the Nubian Plate in the west. Although this separation has been recognized, the exact mechanisms behind it remained a mystery until recently. A study published in June revealed that a substantial release of superheated rock from the Earth's core is propelling the rift. Scientists have long anticipated the eventual splitting of Africa into two, forming a new continent with Somalia and parts of Ethiopia, Kenya, and Tanzania. The study found that the East African Rift System, the visible crack, is propelled by a massive plume of superheated rock from the Earth's core, causing deformations beneath the feature. While Africa is not expected to split for at least another 5 million years, Somalia and portions of Ethiopia, Kenya, and Tanzania will eventually form a new continent when it happens. Ken McDonald, a professor at the University of California, said that no one knows if this rifting will continue at its present pace to eventually open up an ocean basin, like the Red Sea, and then later to something much larger, like a small version of the Atlantic Ocean. Or it might speed up and get there more quickly, or it might stall out, as the Atlantic did before it commenced to true seafloor spreading. But at the present rate, a sea about the size of the current Red Sea might form in about 20 to 30 million years. A 35-mile crack that emerged in 2005 is already indicating the potential for a new sea near Ethiopia. Additionally, another crack tore through Kenya in 2018 following heavy rainfall, leading to the evacuation of people from their homes and the closure of roadways. McDonald expresses his belief that the Eastern African Rift System will likely cause more cracks in the future. The unfolding events prompt questions about the pace and extent of this geological transformation, raising possibilities of significant changes over the next few million years. What could be causing all this? So, although the changes on Earth may not be immediately noticeable to us, the constant movement of tectonic plates is at play. Picture the Earth's lithosphere, made up of the crust and upper mantle, divided into several of these tectonic plates. As mentioned, these plates are not sitting still. They're in constant motion. This movement can result in ruptures, leading to the formation of a rift and the establishment of a new plate boundary, as seen in the East African Rift. This rift divides the African plate into two parts, the Somali and Nubian plates. The rift exhibits different characteristics along its 3,000-kilometer length, with the southern part showing faulting over a wider area, while the occurrence of volcanism and seismic activity is limited. Heading towards the Afar region, the entire Rift Valley floor is covered with volcanic rocks, indicating that the lithosphere has thinned almost to the point of complete breakup. Geologist David Adade mentioned to Daily Nation, a local outlet, that he believed the fissure was initially filled with volcanic ash, but heavy rains washed it away, revealing the crack. Locals, however, reported a sudden and rapid occurrence, with some even feeling the ground shake. The Earth's constant transformation may be gradual on a large scale, but these events remind us that changes can still happen abruptly and make an impact. Scientists believe that the Eastern African Rift System is expanding because two tectonic plates, the Somali Plate in the east and the Nubian Plate in the west, are moving away from each other. This movement, first observed in 2004 by researchers at Delft University of Technology in the Netherlands, indicates that EARS is widening by a few millimeters per year. Stretching from the Gulf of Aden in the north to Zimbabwe in the south, Eyres consists of deep valleys, steep escarpments, and volcanic peaks. This geological feature is an ongoing process of continental rifting, where the Earth's crust gradually pulls apart. The Geological Society of London suggests that it likely formed due to heat flowing up from the asthenosphere, the hotter, weaker upper part of the Earth's mantle between Kenya and Ethiopia. A recent study from Virginia Tech supports this idea. Using 3D simulations of the region, the researchers found that the rift is being driven by the African superplume, causing unusual deformations beneath the system. Continental rifts, like Eyres, primarily occur as tectonic plates move away from each other, leading to the pulling and stretching of the Earth's crust. This process results in deformations that typically form perpendicular to plate movement. Geophysicist D. Sarah Stamps likened the different deformation styles of a rifting continent to playing with silly putty. Stamps, an associate professor in the Department of Geosciences at Virginia Tech, explained that if you hit silly putty with a hammer, it can crack and break. But if you slowly pull it apart, the silly putty stretches. So, on different timescales, Earth's lithosphere behaves like that. As scientists delve into these geographical phenomena, the crack that appeared in 2018 continues to stir debates in the scientific community. Some see it as a real-time sign of continental separation, while others argue that such rapid progression is highly unlikely. Amidst this scientific discussion, individuals like Eliud Njoroge Mbugua, a local resident, bear the impact of these geological upheavals. Mbugua recounted witnessing the crack splitting his home, managing to gather some of his possessions just before his house collapsed. The human experience serves as a tangible reminder of the profound effects that these geological events can have on local communities. The future of the African continent. So, what happens when Africa eventually splits in two? Well, firstly, the breakup will result in the formation of the world's sixth ocean. While the name of this upcoming ocean is still undecided, it's certain that countries like Ethiopia and Uganda, situated directly along this crack, will gain a new ocean and coastline. This new ocean will come about due to the flooding by the Gulf of Aden and the Red Sea, neighboring oceans of Eastern Africa. This change will open up more opportunities for trade and production in the region, and the small Somalian plate will become a mini-continent of its own. However, the creation of a new ocean will also bring about climate change. Currently, Eastern Africa experiences warm to hot temperatures, but the introduction of a new ocean will alter this. Oceans absorb solar radiation, influencing the weather. The surrounding countries might experience more rainfall and even warmer weather. Another concern is uncontrollable flooding. A significant portion of current land in Kenya and neighboring countries will be submerged underwater, and this submersion will likely expand over time as more areas give way to let water flow in. Residents may need to move further inland. As the newly formed ocean between the Nubian and Somalian tectonic plates grows, the island continent will shrink in landmass. Scientists wonder why this crack chose to form in this region, especially given the relatively low volcanic or seismic activity in the area. It's intriguing how a continental rift emerged in this location and has left scientists at NASA confused. So what do you think? Will the African continent be split in two? Let us know in the comments below and leave a like for more.